Welcome to part 2 of our FT10 Demystified series. In this part, we're going hands-on with the front and rear panels of the Valleylab FT10 generator. Think of these panels as the system's face and backbone. Every button, port, and connection plays a role in making surgery smoother and safer. By the end of this walkthrough, you'll not only know what each piece does, but also why it matters. That knowledge gives engineers, clinicians, and techs the confidence to troubleshoot, set up faster, and make smarter decisions in the OR. Let's start by asking why understanding these panels is so important before diving into each feature in detail. Why should we care about these panels? Because in the OR, seconds matter. Every port or button is there for a reason, and knowing them reduces setup delays. So just imagine fumbling with cables or guessing which port is this. Those small mistakes waste time and add stress. In short, knowing this is a real advantage for patient safety and workflow efficiency. The FT10's panel is designed with clinicians in mind. The centerpiece is a touchscreen divided into quadrants, so each connected instrument has its own control space. This layout makes multitasking simple. Just below are the instrument receptacles, 2 ports for monopolar devices, 1 for bipolar instruments, and 1 for ligature tools. Plug something in and the system recognizes it instantly. It's intuitive for users and reassuring for engineers because the feedback is immediate. The front panel tells you at a glance what's connected, what's active, and where adjustments can be made. It's the hub for surgical interaction, making it the busiest part of the generator. Let's zoom in on the buttons. The power button requires a deliberate press. A quick tap turns it on, a longer hold shuts it down. This design avoids accidental activation. The restore button brings back the last configuration. This is handy if you're restarting after a power cycle. Audio lets you adjust tones for activation feedback, while service opens up the settings menu for systems check or advanced configurations. These are simple, distinct, and logically grouped, and all are about efficiency. They reduce training time for new staff and give technicians quick access when troubleshooting. Indicators are how the FT10 communicates silently with the user. The REM indicator part of the return electrode monitoring system lights green when contact is safe and flashes red if there's a problem. It's a fast way to confirm patient safety. Audio tones, meanwhile, provide feedback during activation, signaling whether you're cutting, coagulation, or using ligature. Even the touchscreen colors are meaningful. They're gray when ideal, highlighted when an instrument is inserted, and bright when it's active. These cues seem small, but in a busy OR, they help staff focus on the patient instead of second-guessing the machine. Indicators keep the workflow clear and safe. Flip to the back and you'll find the FT10's connections to the hospital's infrastructure. First is the power cord receptacle, paired with an easily accessible fuse drawer. Next is the Ethernet port used for updates, service diagnostics, and sometimes network integration. You'll also notice several foot switch connectors. These allow the surgeon to activate monopolar, bipolar, or ligature instruments hands-free. The rear panel isn't glamorous, but is critical for stability and safety. Power, networking, and foot controls all route through here. Understanding this layout helps engineers troubleshoot connectivity issues quickly and ensures clinical staff knows where to look when setting up the system. The rear panel also includes external connection points that support the broader safety systems. The equipotential ground lug ties the FT10 into the hospital's grounding network, reducing electrical risk. There are ports for smoke evacuation systems, important for maintaining clean air during electrosurgery. Another connection supports EKG blanking, which helps prevent interference with cardiac monitoring during monopolar activation. Each of these ports shows how the FT10 isn't just a standalone device, it's part of a much larger ecosystem in the OR. For engineers, checking these connections during service ensures smooth integration with other hospital equipment and reinforces overall safety. Let's put this into context. A nurse plugs in a monopolar pencil and instantly the touchscreen shows its settings. No extra steps needed. A surgeon connects a ligature instrument and the system automatically recognizes it, adjusting options accordingly. Meanwhile, an external smoke evacuator ties in through the rear panel, kicking in during activation to reduce airborne risks. These aren't just features, they're workflow improvements that save time and improve safety in the OR. By seeing these examples, you get a sense of how the FT10 is designed to feel seamless for the clinical team, while still giving engineers clear points of oversight. If you are an engineer or technician, there are a few habits that pay off. First, check that unused ports have their protective covers on. They prevent contamination and wear. Second, verify that the REM system is functioning before procedures. It's a quick test but critical for patient safety. Finally, always confirm activation tones. These audio cues are a safety net in the OR, and if they're off, clinicians will notice immediately. Building these checks into your workflow means fewer surprises and smoother support for the surgical team. Simple habits like these keep both the machine and the people working around it confidently. The front and rear panels are more than just hardware. They're the FT10's gateway to safe, efficient use. Knowing their layout, functions, and signals turns confusion into confidence for both clinical and technical teams. By now, you should see how each port, button, and indicator contributes to the bigger picture of surgical safety. In the next part of this series, we'll dig deeper into operation modes and explore how the FT10 adapts to different surgical needs. Thanks for joining this walkthrough and stay tuned for part 3 of the FT10 Demystified series, where we'll continue building a practical, engineer-friendly view of this system.